Is there any limit to the mass of an object in the universe? Can something, like a black hole, become so massive that it can rip through the fabric of spacetime? Or would physics prevent that? Or is there no upper limit to the mass an object can be? Honestly, we don't know. It also depends on your definition of rip through the fabric of spacetime, since many people would consider any black hole to have done that already. It also depends on what you define as an object. Does a galaxy count? Or a cluster of galaxies? Both are gravitationally bound, so may be considered an object. The single most massive discrete object detected so far would be the black hole TON 618, which masses 66 billion times the mass of our Sun. It's a tough question to answer, because as of right now we just don't know enough. But TLDR, there's no limit that we know of, but it doesn't really make sense to ask this question at all. If you're referring to things being anything besides a black hole, then yes, we have a very precise value for how much matter we can cram into one spot. Even then, it's hard to think of this grouping, a neutron star, as one object, because it has several different distinct parts with unique properties. And if you're including black holes as it sounds like you are, then it becomes much trickier and more complicated. It might help you to learn a bit more about how black holes behave. Black holes aren't things. The event horizon, which is commonly explained as the point of no return, is actually exactly what its name implies. It is the point at which actual events stop happening in a physical sense. Black holes are collections of events, and those events stop meaning anything past the event horizon, at which point four-dimensional spacetime no longer exists in the way it does outside of black holes. The three spatial dimensions collapse. If you were to travel past the event horizon of a black hole, any direction that you move, back, up, down, etc., will move you closer to the center of the black hole, because 3D space no longer exists as a concept. You wouldn't be able to tell that this was happening. An outside observer would simply see you freeze on the horizon and completely stop moving, and very, very slowly become dimmer and dimmer until you could no longer be seen. To an outside observer, the physical event of you moving towards the black hole terminates at that spot. Black holes also do not suck anything in, including light. It's a helpful analogy, but it's not what's really happening. There is a concept called redshift, where light from distant stars, galaxies, anything has its wavelength altered from our point of observation on Earth because spacetime is continually stretching as the light is traveling through it. Black holes are black because the light that is nearby, moving towards or away or in the general vicinity has been redshifted to infinity due to spacetime warping, which makes it impossible to detect. But that doesn't mean it has been sucked inward, just that the light can't ever be seen. What I'm trying to say is that even though you can think of there being a singularity at the center of a black hole, as many others have mentioned, there probably isn't, and it just implies we don't know enough about it yet. Where all of the mass is gathered or is moving towards, positional space collapses past the event horizon. Outside of a black hole, you can think of them as objects because they behave like objects. If you take a black hole of identical mass as a star and swap it into its place, nothing orbiting it would even know the difference. In that sense, no, there does not seem to be a mass limit for black holes, and there isn't a mathematical reason that they would have an upper limit. Hope this kind of makes sense. I was trying to avoid using terms like geodesics to not make it overly complicated. But let me know if I can explain anything further. As an aside, black holes aren't really tears in spacetime at all. As of right now, the only hypothetical possibility for an actual tear would be if the Higgs field isn't in its lowest energy state. We don't know if it is or isn't, and its energy lowers, it would annihilate all of spacetime and remove all matter from existence. This would happen at a singular point where the field energy lowered, and move outward to consume the entire galaxy at the speed of light.